right. So yeah, great to be here, everybody. I'm André. I'm the founder of a company called Encore. I've been doing that for about a year now. Long time Go developer. I was at Spotify for many years. And when I'm not taking care of my little startup, I'm taking care of a puppy called Salvador. He's really cute and incredibly playful. And today we are talking about fusing IOFS with Gopls and building a cloud-based Go editor from scratch. And to give you a bit of background why you would do something like that, I want to give you a brief background about what we're doing with Encore. And what it's really all about is that we see that building modern backend applications is incredibly slow. You have to do a lot of work connecting servers and databases, build systems, and setting everything up together. And most of that work is just essentially like digital plumbing. And you end up spending fairly little amount of your time on building your actual application. And that's what we're trying to solve with Encore. It's like a framework for Go with superpowers specifically designed for building distributed systems, with a goal of making it like way less boilerplate. We do a lot of static analysis and code generation to do things like setting up infrastructure, automatically instrumenting your application with tracing and so on. And we've gotten pretty good feedback about this, but actually trying out the product is like there's some friction involved because you have to download a binary and install it on your system and so on. So what we wanted to do is we wanted to create the same experience directly in the browser so that you could have like a Go editor that is like Encore powered, so to say, directly in your browser. And so that's the challenge. Like, how would we actually build something like that? How would we build a lightweight, web-based code editor that uses Gopls for code intelligence? And it seemed like a pretty tall order, but we didn't stop there. We tried it anyway. And like, I've been a software engineer for a long time. And usually when I try to innovate on something, I don't know where we're going necessarily. Like, I know roughly what we want to do, but I'm not really sure how to get there. And usually that the way to actually get to a solution is a lot of like stops and starts where you're trying to figure out like, okay, this is roughly where we're going, but we have this problem. Okay, we could solve that problem in this way. Okay, but that leads to another problem. And then you need to solve that problem. And then you just keep on doing this, and gradually a solution emerges. And so we started, like, we knew we wanted to do this in the browser. And we knew we wanted to use Gopls for code intelligence. But how would you connect them together, right? Like, you can't really run Gopls in the browser, or it would be very complicated. So how would you do that? Well, Gopls actually has really good support for JSON RPC, which is like the standard language server protocol for communicating. And so we figured out that we could actually connect them together via WebSocket. So that's one problem down. But then it turns out that Gopls actually uses the file system. Like, all the files have to be there on disk for it to read and understand like how your project works and cache and index all of the Go packages for code intelligence. And that's quite slow, right? And especially if you have a larger project, that can be a lot of time spent reading and writing to disk before you even start up. So we figured, why don't we do it in memory instead? Okay, so how would you do that? Well, it turns out there's this thing called a Fuse file system, which is like essentially a in user space file system that you can program directly with like a user space program, like the ones we're writing. But then there was a problem that, like, aren't Fuse file systems really complicated? But it turns out that there's actually a really, really awesome Go library for writing Fuse file systems. It's called the Go Fuse, and can really recommend it. So even if we did that, we have this problem, like, how would we load all like a really large code base at once? That would be really slow. So I figured out, could we do it lazily instead? Could we fetch this data from a Git repository as it was needed instead of fetching everything at once? We could use either GitHub directly or host our own internal Git server. It doesn't really matter. And so in this way, slowly a solution emerges to the problem, right? And what's really nice about structuring a problem and a solution like this is that you break it down into smaller components that together combine to provide a lot of advanced functionality. And in my experience, you can actually tackle most problems in this way. And by doing that, you can break it down and it becomes much easier to reason about. So there are three main concepts that we should explore, right? Like how to actually make this a reality. And the first one is Fuse and file systems. The second is, could we use the new IOFS package to do all of this instead of having to write like fairly complicated Fuse file systems? And the third part is, like, how would we integrate that with Gopls? So first of all, let's dig into Fuse and how that works. And like I described, it stands for file systems in user space. I couldn't really figure out if it's like this or like this, like the acronym. So I'm letting you decide which one you prefer, but I'm gonna go with this one. And the way it works is when you're interacting with a file system, like writing ls/foo, that goes into libc, which is doing a syscall to the kernel. And this is hitting the virtual file system module in the kernel. And that consults its table of all the file systems that have been mounted and figures out which one should we actually send this request to. In this case, it's a Fuse file system. And what happens is that actually gets sent back out into user space. And it goes up the stack again from libc into libfuse, which is the user space component of Fuse. And that calls out into your program, which is actually the program that's providing the file system. And all of this is made possible by this really awesome library. You should definitely check it out. It's super interesting. They have lots of great examples. So if you're interested in playing around with something like this, then just check it out. The next part is around IOFS and like building a file system in a simpler way instead of using Fuse directly. And if you haven't looked into it yet, it's a new standard library package in Go 1.16. And it actually has a very simple interface, primarily around opening files. And then there are like companion interfaces for actually doing file operations. And it's worth keeping in mind that today it's designed for read-only file systems. But that's enough for a lot of use cases. And hopefully it will be extended for writable file systems over time. So the big question is, can we use Fuse together with IOFS? And it turns out that we can, absolutely. And all we really have to do is write like an adapter that is taking like the IOFS interface and wrapping it up in the Fuse interface, and have that implementation for every single operation that the Fuse file system does. It calls the corresponding implementation in the IOFS package. And this is, it's not really complicated, but it's a bit annoying to do over and over. So I created a Fuse FS package, which is now open source. You can check it out, and it really makes you can just like wrap it in one line, and then you have a Fuse file system that is implemented using IOFS. So with that, the big challenge ahead of us is how could we actually serve a Git repository implemented as an IOFS file system? And to better understand that, we need to start by looking at the Git data model. And if you, like most people are aware of commits and how you're interacting with commits, but not everybody knows the underlying Git objects that make up a Git repository. So to cover that very briefly, this is like a commit object. It has a hash. It has a parent commit. In this case, it's the root commit, so it's null. It has an author, and the final part is a tree object. And this is just a hash in the same way like a commit hash, but it's pointing to a tree object instead. And a tree object is essentially just a directory. It has a list of contents. And those contents are either other trees, and that would be like a subdirectory, or they're blobs. And blobs are essentially files. So here you can see that there are two entries in the root of this repository. We have a README file, and we have a command directory. And this blob object is pointing to, the blob entry in the tree object is pointing to a blob object, which has the actual contents of the README file. And the tree object, or the tree entry is pointing to a different tree object, which has the main.go file. So in this way, you can see how Git is building up a file system by having these objects and linking between them. And what's really nice about that is if you make a change in a commit to one file, it doesn't have to rewrite the whole repository. It's just changing the tree object that was modified and their parents, as well as the blob. So everything else stays the same. So when you have a new commit, the big difference is it has a parent pointer, which is pointing back to the previous commit. And then this has its own tree, which has a different blob because we changed the README. And the tree is, for the command directory, is pointing back to the same tree object from before. And this tells Git that this whole subtree was not changed at all during the commit. And that helps like doing diffs very quickly. So once you have this, the big question is like, how would we use this to build like an IOFS implementation that queries this data model to only serve the things that we're actually interested in? And it turns out that's actually really, really simple. There are essentially two parts to it that we need to implement. One is this Git node, and this is like the data structure that captures like every node in our file system, whether that's a tree or a blob. We need to store the object hash of that object. So the tree hash or the blob hash. We need to know the path to the object in the file system. And finally, we need a way of actually fetching the tree that it is pointing to from the Git server. And we'll do that lazily when it's actually needed. And you would think like, okay, but you've just shifted the problem, right? Like now we need to do all of this fetching of Git objects from remote repositories. But it turns out that there's actually a really awesome open source project for that as well. So this is another open source project that you should absolutely check out. It's the Go Git project. And it's incredibly powerful. It implements the store interface that I just showed you with some minor changes. And what's more is they implement like almost every Git operation you can think of. So if you want to explore and modify and play around with Git from Go, this is a really, really excellent package. And so what I did was I packaged up these concepts and open sourced that too. So this is now available as well. It's a Git FS that is essentially doing this where you can stream directly from a Git store into an IOFS implementation. So now that we have that, the final step is figuring out how to integrate all of this with Gopls. And these are gophers that I'd like to think that they are asking for permission to eat the other's food, but I'm not sure exactly. So what's Gopls and what's the problem it's trying to solve? So it's a language server, and a very brief primer on that is before the language server protocol was invented, or LSP, every time that you wanted to do code intelligence, you had to integrate like every language with every editor. And that became an incredible amount of work. So Microsoft invented the language server protocol, which essentially abstracts away this difference and provides a unified protocol for doing code intelligence. So then you need to write a single language server per language. And then each editor can integrate once towards that language server protocol. And to briefly explain how it works, it's JSON RPC. It is essentially a bunch of requests and responses back and forth. And sometimes there are notifications that there's the same thing like a request response, except they don't have a response. So it's just like a one-way notification. So for example, you start out by sending a notification that you open a document, and then as you're making changes, you're communicating those changes. The server is recording all the changes and updating its in-memory state. And then it's feeding back like, oh, you have an error over here, or you just typed invalid syntax, and so on. And when you want to do something like code intelligence, like go to definition, you send a request to the server, and it responds with the result. Like you can open up this file. This is where the definition is. And then the client would have an implementation of like, okay, we're going to open up that file in our editor. And this is essentially how it works. It's relatively simple. It's a lot of work to actually build a language server. So fortunately for us, Gopls has been under development for quite a while now and is incredibly good, and it's getting better with every release. So we don't need to do that. We can just use Gopls. So with that, we're going to take all of these pieces and really connect the dots and put this together into something that works. So we have our browser from before. We want to have a WebSocket to Gopls. But it turns out that if you do that, how are you going to set up the Fuse file system? You can't really. So we put a proxy in between. And this proxy is essentially like a WebSocket server that is listening on like when a connection starts, and then it mounts a Fuse file system and rewrites the path to Gopls so that it will actually look in the file system. And then Gopls will read from the Fuse file system, and we're done essentially. This is the core, and then the Fuse file system will query GitHub or whatever Git repository we want. There's just one problem remaining, which is that Fuse files, Gopls actually needs write access to the file system because it does a lot of changes to files over time, right? And it's writing them back. For example, Go mod files and so on. So we actually need to do slightly more work to add like a writable file system so the Gopls can actually write these files. And since we're actually serving this from Git, that's very much read-only. So we can't really write to Git directly. So what we need to do is we need to overlay an in-memory writable file system on top of all of this. And the idea is that we'll extend IOFS with a way of opening files for writing that will wrap the underlying read-only file system. And once we do that, when we're actually writing files, we'll only do that in memory. And this overlay file system will shadow the original contents. So in that way, you get a writable file system on top of a read-only file system. And we did that too, and open source that as well. So you can check that out. And what's really important to remember is these are all like very reusable concepts. So you can really mix and match them however you want. You don't have to use the overlay file system with Fuse or with the Git file system. You can really mix and match them however you want. And that's the big power of the IOFS package. And with that, I want to do a quick live demo to show you the finished product. Hopefully it will help you understand how all this works. We are working on open sourcing the front-end part as well, but that was a bit more work to actually pull it out of our web application. So that's something to come after this. So I'm going to share my screen. There we go. So this is a very, this is just like our Encore's cloud platform. When you do edit, you get this cloud-based editor. You can open up all of these files, and it's like a regular editor, so we can just start typing. And you will see here that you're getting code intelligence as you're typing. So let's create a simple endpoint just to demonstrate. So say the input is a name, and we'll create a function which takes a context. You can autocomplete everything, autocomplete types as well, and you can just return the same type that we have above. We'll construct a message out of this and say hello, and take the name, and return. Scroll up a bit. If I pass in the wrong field, you will see that we get a compile time error over here. You can hover over that, and you get the error contextualized where it's happening. So we would then fix that, and then we're done. So as you can see, this is maybe not the same level of polish as you would have in Visual Studio Code or otherwise, but the core principle is the same. We're getting all of this feedback directly from Gopls, and all we have to do is really listen to the messages they're sending and then rendering them in the UI. What we're doing here is using CodeMirror, which is an open source JavaScript editor, but you can really do whatever you want. So with that, thank you so much. All of what I just showed you is open source. So check that out at github.com/encoredev/FLSutil. Thank you very much.